Hey, hello, welcome to the show. It's me, John Park, and this is John Park's Workshop. Thanks, everyone, for tuning in. I am just going to touch that mic level down a little bit, but that looks pretty good to me. Let me know how that is sounding in the chat. I've got my new mic and a new audio input. Actually, the audio input is just stolen from another place in my studio audio life, but it looks like it's peaking a little above 0 there. Oh no, not on the master output. Okay, looks like it's about minus 3 dB, which sounds good to me. But let me know how it sounds to you, the listeners, the viewers. And if you're wondering how am I staying in contact with you, well, we've got our YouTube chat. Hello, Dave Odessa. Thanks for stopping by over there. And then our main chat, if you're somewhere without a chat, is this right here. It's our Discord. And you can head over there by going to adafruit.it/Discord. Look for the live broadcast chat channel right there. We have a bunch of channels, but the live broadcast chat channel is where people are hanging out. Thank you, Paul Cutler says the sound sounds good. Hopefully I didn't tweak it too many times since I asked. And Blitz City DIY, hello Liz, hello to Andy Calloway and Starman, Sam J, Ohio, thanks for stopping in. We are doing stuff with compressors today. You can see an air tank right there. Starman asks, what are we learning today? So, well, that's a great way, a great prompt for me to talk about what's going on the show today, particularly if you're new to the show. What is this? This is my workshop. I'm going to talk about some things, give you some discounts on buying stuff from Adafruit. I'm going to build some stuff. I'm going to do a CircuitPython Parsec where I show you a little tidbit of info that can be helpful with CircuitPython. I've got a recap of my product pick of the week. I'm going to do a Learn Guide recap. And time permitting, I'm also going to dive into a little bit of some intro CAD with Rhino stuff. But the Rhino part's not so important as the intro CAD, and that can progress into more advanced CAD topics, parametric design, design for 3D printing, design for other forms of fabrication that I'm going to be covering, and I'll be looking for feedback on that as I go to find out if that's something you're interested in and if I hit the right kind of level of new stuff to understandable stuff if you're new to this. So hello to Hacho Gonzalez. I'm sorry if I've mispronounced your name. And you're right, it sounds like it's only in the left ear. Let me fix that. I appreciate the feedback. I'm going to switch the audio output to, that should now be in 2 ears. Oh, interesting. It's not outputting in both. It is, I've got that source as dual, but yeah, it looks like, does this fix it? Does this fix it? No. No. That should be nothing now? Huh, weird. The place I can map that doesn't seem to care. Let me check the output. Check, check. Check, check. That doesn't change anything. Check. Oh, that kills it all. Test, test. Oh, that's going to monitor on my side. Hey, weird. I just fixed this on the other show on Tuesday, but this one's not letting me output both channels properly. Hi, Thin Man. You are not late. I am just ironing out my new, newly plugged in, at least, audio input. And trying to figure out, even though, that's funny, my preview mixer shows that I've got sound only in both sides, but my output, final live output, is saying that it's only in the left channel. Let me think. Is there an overall output I can tweak? Maybe. Check. No, that's going to echo. Format, no, no, and no. Yeah, weird. Apply to all. Check. Okay. That should have done it. There's an apply to all button that seems to apply my settings to some mysterious other place that I can't seem to find in the interface. All right. Well, yeah, thanks, Thin Man. It's true. A lot of the time you might not know that someone's broadcasting accidentally only in one channel, because a lot of time we're listening through like a single mono speaker. But if you're in headphones, that can be maddening, I know, or if you've got a bit of stereo separation. But now it looks like I'm outputting in stereo, and I'm just going to do one quick thing, which is save my setup. There we go. Okay, I saved my setup. I think it probably hiccuped for a moment when I did that, but good news is, thanks to Acho Gonzalez, we now know that I was in mono, and now hopefully stereo is working for everybody. That did it! Yay! Thanks for your patience. I appreciate it so much. Okay, let's have a sip of water. Or whatever beverage you want to have. Okay, so what's going on? I have a coupon code for you. So it's October, and the coupon code is Octomonth. That's right, it is the 8th month of the Roman calendar, October, which happens to be the 10th month, but we didn't rename it, confusingly. Was December the 10th month of the Roman calendar? I bet it was. How come we don't use that convention for all months? I don't know. But either way, if you want to save 10% off on an order from Adafruit today until midnight tonight, East Coast US time, well, then this is the coupon code for you, Octomonth. What you can do, how do you use this? Head on over to Adafruit.com. That's the store page right there on the front page. You don't have to dig around for it. We want you to buy stuff. You can see we got a nice little banner here of some new products. You can take a look at some of those, throw them in your cart. On the way out, type in the coupon code, Octomonth, and that'll get you 10% off. Let me peel off the background here so I can post that in front of my window. There we go. So right there at Adafruit.com, check out products. If you hover over this products link or the what's new link, you can take a look at some new stuff that we have in stock. Throw the things that are in stock in your cart. There's no back orders with Adafruit. We've never done back orders. It causes too much heartache. So if you see it, it's in the store, it's available to ship, throw it in the cart. On the way out, type in Octomonth in the coupon code slot, and you're going to get 10% off the order. And there are, the only restrictions are that works for physical stuff that we can ship you. It does not work for gift certificates or subscriptions or what else? Software. I don't know if we're selling any software currently, but at some points we have licenses of EagleCAD and things like that. I think long time ago we used to sell or resell. Either way, use that coupon code for physical stuff, not for imaginary things. So that'll get you 10% off in the store, and you can use that until midnight tonight. Also, I will mention, if you're buying stuff and you have a bunch of, whoops, that's not the right, there we go. If you're buying stuff, you have a few places where you can order enough to spend enough of your hard-earned money to get free stuff. So if you're wondering what those things are, you can just go up to adafruit.com/free. Type that in. That will take you to this deals and more at Adafruit page, and this will show you right now we've got, if you spend $99 or more, you get a free PCB coaster with the lovely Adafruit logo on there. If you spend $149 or more, you'll get a KB2040, the keyboard board, for free along with the coaster. If you spend $199 or more, you get free continental ground shipping in the United States, as well as the microcontroller and the coaster. And if you spend $299 or more, big order, you're going to get a free Circuit Playground Express and the ground shipping and the KB2040 and the coaster. So head there to find out about those. You don't have to do anything. They'll just be automatically added to your cart. As you put enough in your cart, you'll see those items appear with a $0 amount. So let's see. Let me take a look at some questions over in the various chats before we move forward. Let's see. Hello, 3D Tech Guy over in our YouTube, as well as Andrew Farnsworth, who, thank you. You were another person to mention the stereo mono audio issue. And let's see. How do I pay with euros in the Adafruit store? I do not know. I think it depends on which country you're in, but we may have a, let me check. I'll check this live on air. We may have an answer to that in the bottom of the page under shipping and returns, or FAQs. Check those. Also, if you check the distributors link down here, we've been featuring some distributors, resellers of Adafruit stuff around the world, so check there. You may find a local reseller is a better place to buy from. But check those places. And then you can also ask a question over in the tech support forums or in the one of the Discord forums. I'm trying to figure out what would be your best bet on that one. It may be a general, you may try it just in the general chat, and you may get redirected from there to somewhere else to ask that. But yeah, buying in different countries, good question. Those are some resources for answering that. So, and if anyone in the chat knows, because I know we have various people in Euro using countries in our chats, let me know in the Discord chat. I'll read it out if there's an answer that'll be helpful for people over in the YouTube chat, and vice versa. 3D Tech Guy said, I just made a microbit elevator demo with a DC motor and the motor driver. Very cool. You know, that reminds me, one of my very first dioramas I built in like elementary school was a cardboard elevator that just used straws and string to wind up like a little winch and lift the elevator. It wasn't very safe. All right. Let's see, what else? In the chat, someone mentioned that in the UK, Pimeroni stocks some Adafruit stuff. Good tip there from Andy Callaway, thank you. All right, so next up, I've got a show on Tuesdays. It looks like that, and it is the product pick of the week. And on the show, I pick something, usually something new from the Adafruit shop, and give you a deep discount on it. And then we do a little bit of a demo, about 15 minutes. You can tune in, get the discount live. It's a show that is actually broadcast from within the product page. All that info shows up on Tuesday in the blogs and on our various socials. And I like to do a little bit of a recap here that's just 1 minute long, so check it out. That is the product pick of the week. This week it is the Feather RP2350 with high-speed transmission port. There's another one. I put this one on a little breadboard with the Feather headers. It comes with the Feather headers you need if you want to plug that in. And then I just have it running to an external button here that I can use to trigger audio that's coming out of one PWM out. When I flip the switch, we should hear that THX deep note. So here we go. It is Feather RP2350 with HSTX port. Yes, indeed it is. So that was product pick. We sold through those during the show. I think we had 100 of them in stock, but I believe we have a, that was like the first batch that we made pretty much. So we have a new batch in the works. So you can always head to a product page. This one's product 6000, so it's easy to remember. You just go to adafruit.it/ and that number, or type that number up in the search bar. You'll see it says it's out of stock right now. You can type in email, hit notify me, and you will get an email when that comes back in stock. You can also, on Discord, go to the new products forum, or channel rather. I believe that will show when stuff comes in stock. If not, it shows when the newest things come out, but that's kind of an interesting resource for keeping an eye. Yeah, maybe it's not for stock, but that's kind of an interesting resource for just when a new thing for the first time hits the store. And I think in Discord you can subscribe to feeds in various ways, so that even when you're not over on a particular server, you'll get info about it. So you can go check that out. All right, so let's see. Next up, let's do a CircuitPython Parsec. How about? CircuitPython Okay, so let me get my browser window visible here as well, because for the CircuitPython Parsec today, I wanted to show you how you can use CircuitPython.org to get the absolute newest cut of CircuitPython. And I think it's pretty appropriate to show this on this brand new Feather RP2350, because things are changing rapidly. You may have bugs or limitations that are changing on an almost daily basis. So sometimes it's fun to stay up with the most current version of CircuitPython rather than waiting for betas or releases. So here is how you can do that. We're going to head to CircuitPython.org. Then up at the top in this sort of second menu section, you can click on Downloads. That will take you to selecting your board. So we're going to pick a board if we don't see it just showing up right at the top there. So I'm going to do Feather RP2350. You'll see the board shows up. It's actually a green prototype version. So I'll click on that. Now, you may be used to the first couple of big purple buttons over here on the right, which are download the UF2 now. So that'll get 9.2.0 beta 0. That happens in this case of this board to be sort of the release one. For other boards, you usually won't see a beta at the top. Then if we scroll down, often that beta will show up, but in this case, this one's so new that we can head right here to absolute newest. And this says browse S3. That's Amazon S3 as our storage, our cloud storage for all of these builds of the UF2 and binary that we want. So I'm going to click on that link. It's going to take me to a directory structure here. And here you can pick the language you want to use. So I'm going to use English US, but you can see we have a whole bunch of other options here that are automatically built. So I'll click on English US. And then I'm going to scroll just sideways a little so you can see the full name there. Here you can see I've got these time-stamped builds. So these are happening every few hours, it seems. And this one on the top here is the one I'm going to grab. So that says Adafruit CircuitPython, followed by the name of the board, Adafruit Feather RP2350, the language, English US, the date here, 2024, October first. So this was last built a couple of days ago. And then the PR number for that, so the exact version of this is. And then this is a UF2. So when I click on that, that's going to download to my machine. And then I can go and click on the reset and boot buttons to put this board into a bootloader. Before I do that, I'm going to head back to a code view here where I can just take a look at the boot out text that's on my board currently. So for this board right here, it says we're running 9.2.0 beta 0. Okay, that's good. Now what I'm going to do is put this into the bootloader mode, and I'm going to drag that UF2 file onto this. You won't see that on screen. I just don't have a window visible, but this will be this newest, absolute newest that I put on there. So that'll take about a minute. So it's uploading to the board. It says 0 bytes of 1.6 megabytes, estimated time remaining. And then it's just going to take however long it's going to take here. So I'll wait on that. Okay, so it just finished. And then I can close. I'm going to reopen the bootout.txt that lives on the Feather board. And now you can see we're running this, instead of beta 2, we're running this much more recent one that I've just downloaded. So these are all versions of this, but they have their own release numbers. So that is how you can head to CircuitPython.org and download from S3 the absolute newest cut of CircuitPython. And that is CircuitPython Parsec.
CircuitPython Parsec.
Oops, sorry. Yeah, no audio. There we go. Audio's back. That's just me not clicking on something. Thank you, Paul, Andy, Dave Odessa, everyone who let me know. I appreciate that very much. Sometimes I miss it entirely. That's very helpful. Okay, so next up, I was just sort of recapping what I did there, so you didn't miss much while my mic was off. Unless you're a lip reader. So now what I want to do is a quick Learn Guide recap of the HID reporter. That was the project from last couple of weeks that I was working on, and now I've got the Learn Guide published. So if you're ever wondering where to find these, just head to adafruit.com. This will take you to main adafruit.com. Up at the top, look for the Learn link up at the top there, or you can always just type in learn.adafruit.com. And the newest 4 or 5 guides are visible up here in this banner. Actually more than that, more like 8 of them or so. You just have to scroll sideways. These are the latest guides that have either come out or been updated. Those are often in there as well. You can also click on the View All link next to New Guides, and that'll take you to the newest stuff. Bunch of cool guides came out last week. I think just in this past week, the Qualia, It's a Snap, the Prop Maker, Jack-O-Lantern, HID Reporter, Fog Machine with Motion Sensor, It's a Snap Apple Health Status, and HomeKit with It's a Snap. So a bunch of cool stuff. I haven't checked out It's a Snap or the Apple shortcuts yet. I need to do that. I need to get on that. That looks interesting. But this guide here is the one I just finished working on. This is a way of just getting the hex code of key presses from an HID USB keyboard. It's a pretty simple build. You can do it with just a Feather board and a Feather wing. Feather board in this case was a ESP32S2 with the TFT on it. Here's a closer view of it. And the Feather wing is the USB host Feather wing, which uses the MAX 3421E. Is that the right number? No, I've got that name. What's your name? Maybe that was it. MAX 3421E, yeah. That's a USB host chip. So that's hosting USB, and then you can power the Feather over USB. You can also power the Feather over battery if you want to keep it portable. And then you plug in keyboards or even mice, and some other devices will also comply with showing their vendor ID, product ID, and the hex key codes of the key presses, up to 6 of them. So it's the first 8 bytes of that USB HID message shows up. And there are the parts. I used a little feather wing doubler to put those together. You could also put a stacking or female headers on the USB hub, or rather the USB host feather, and then plop the feather on top of it. You have a little candy bar sized build. And so here's some basics on putting it together. There's the orientation of just a couple of sets of header pins underneath and header sockets on the top of the doubler. Plug them in and you're ready to go. So it's a pretty simple build. There is a page on setting up Arduino IDE. If you don't have that set up and ready to go and uploading, it'll take you through some info on libraries, as well as just uploading your first Blink sketch so you know everything is working. And then I've got the code page here. You can click download file. That will get you the full directory that you want to use. So do that because there's some added files, USB H helper.h file that you'll want to grab. But this is the code just listed in a nice readable form. And then I have an explainer of what's going on in the code that you can check out so you know why it's doing what it's doing, and you can modify it if you want. And then here is a demo. I've got a little demo GIF here of in action. That's the 1 key, the 2 key, both the 1 and the 2 key, and then a whole bunch of keys being pressed. And then when you unplug, it'll report that you've unmounted the device. Often you can then plug in another device. If you plug the same device in twice, it sometimes needs a reset for some reason. It just doesn't tickle the system enough. So powering it, like I say, you can use USB-C from a power bank or from a laptop or a desktop computer, or you can just use a LiPo battery if you want. Plug it in and off you go. And you can see here a different keyboard, same results. So these are sending the standard hex key codes there. And a little bit of troubleshooting info there. If you run into issues or come up with neat tips, let me know. We can always add them to the guide in the troubleshooting section if you have any tips. We have a feedback link, by the way, if you're new to the Learn Guides system. Up in the upper left of a guide, click on that, and that gives you a form to send in any notes that you have. So there you go. That is the HID reporter. All right, so next up, what I'd love to get into is all this jazz over here. What the heck's going on here? So let me, oh good, hopefully I have solved, knock wood, my camera or my audio issues, and now it's time to possibly get a new camera. This one overheats a lot. I think it may be old age, because I've got the AC kind of pointed at it. I'll keep that view small and I can pivot a different camera if it goes out. So let me head over here and then we'll talk about what we're doing. So this is going to be a Halloween haunt air cannon prop or device. Take that tank out of the way there for a second. And so if you're familiar with things like a t-shirt cannon or something I made back on the Make TV show, the Burrito Blaster, it's essentially a pneumatic cannon blaster device that stores compressed air in one chamber and uses a solenoid valve to dump air out of it, a whole lot of it, so that you can launch something. And depending on the build, you can get multiple shots out of your compressed air for small little scare effects. So you'll run into this in haunted houses sometimes. You'll see these sorts of things all over the place at theme parks where there are hits of sound and air, things moving, confetti cannons, same kind of idea. And so what I want to do is put one together. It's basically common hardware store parts that I will use, and then some electronics. And some of those electronics will be so that we can trigger things with a CircuitPython running Feather prop maker, which has the ability to drive a little relay, which will open and close our solenoid, to add input of sensors if we want to use things like a distance sensor to sense when someone gets close enough to fire the thing. I will warn, these can be dangerous. We do not want to be shooting these at people's heads and faces. These are often pointed at a wall or something, so they make a burst of sound, or they're used to launch a prop, shoot confetti into the air. If you have a pirate-themed thing and you want to shoot a cannon and have a nice boom sound, you can use this. You can add resonators to make it really loud. You can also use airline, like plastic hose, to do little ankle tickler type effects. So there are a bunch of things you can do. One thing you don't want to do is shoot people with these. So keep that in mind. I don't want you to blast people. I don't want you to fire projectiles out of this kind of thing. It's dangerous. So let's talk about the system here. So first of all, we're going to have a source of compressed air. And for this, I'm going to use a little 5-gallon air tank. This is similar to what you'll see built into an air compressor. So air compressors are usually a motor that forces air with a pump into a reservoir. You can get that as an all-in-one unit. However, those are going to generally have a small airline on the way out. So what we're going to do is leave our compressor alone. We're going to use it to fill the tank, but the tank itself we're going to modify in a very simple way, a very safe way, so that we can get the most air out of it the quickest, so that we can get the best effect. So this is an inexpensive, this is from Harbor Freight. These are like $35 at Harbor Freight, and they are meant to fill up with air. You can see this has actually got a bicycle pump valve on there. Is that a Presta valve? I think it's a Presta valve with typical bike pump threading. You can use an air compressor with that type of connection on it. I'm going to zoom in a bit actually for a moment here. Let me refocus this. So you can see here, this is what you'll find at the gas station when you go to fill your tires with air. A Schrader valve. Thank you, Andy said it's a Schrader valve, not a Presta, a Schrader valve. So this is going to go just like that, fill this thing up. This is how it's meant to be used. We're going to be removing this actually. But what this does is it lets us see how much pressure we put into it, and then we can essentially turn the whole thing off so that we're not letting any air out of here, or open it up so that we can let air out to fill up our bicycle or inflatable raft or whatever it is. So that's how it's meant to be used. Let me demo that real quick so you can just see this in action. I have already removed this once and screwed it back in for this demo, so I didn't put any compound or Teflon tape on there, so it may leak a little bit, but that's okay. Down here I've got just a old Power Pal. This is an air compressor here, so I'm just going to leave that on the floor and turn it on. Maybe I need that open. Okay, so you should see this start to go up. I don't know if you can hear me if I cup the mic there, but I'm going to put maybe 20 pounds of pressure in there. Okay, so that now, sorry about the noise, I maybe should have warned you. So that now has 20 pounds of pressure, 5 gallons of air in there. It is ready to go fill up a bike tire or something. I don't have anything here to fill, but you'll just hear it as I open the valve. Okay, so I'm actually just going to let that out. See that draining down. One safety feature these have that I may incorporate in the design, or at least put a disclaimer that you should, is it has an overpressure valve. So this tank is meant to go to 150 or 125 psi. This is a little overpressure, so if the pressure gets too high in here, this will push out and let out air before anything explodes. So I may incorporate that in the design. Okay, so this, let's take this off. So this is going to be the first step, is that what this one has, and it's a good one to use. In fact, if you look on Halloween Haunt suppliers who build these kits and sell them, they pretty much all seem to use a similar or this exact tank, and they paint them black so that it hides the fact that it's a Harbor Freight air tank. But so this we could reuse maybe, depending on how you want to put things together as the inlet and pressure and overpressure valve. But I'm just going to put all that off to the side for now, and I'll see if I end up incorporating any of that. So now we've got this with a 1/4 inch outlet, inlet and outlet. So I'm going to set that down and show you what we're going to build instead of using that. Yeah, let's look at individual parts first, and then we'll. There we go. Sorry, just getting that into focus. So this is going to be the airline input, and the way I'll use that is if you look at these 1/4 inch quick connects, they just clamp right on there and seal. So that's how a lot of your different things, like here's my sprayer that I use, right? That just clicks onto there. So your air compressor will usually have this type of 1/4 inch quick connect. So that'll go like that, and that's how we'll fill it. So that's the first thing. And then I've tried to keep this compact in most places. There's some places where, to avoid things bumping into each other, I had to go with some longer pipes. So I went with a male threaded connector to a ball valve, and so this will go in like this. When I put this together, and I'm not doing this right now because I got to take pictures of it for the guide, I'll use Teflon tape on that to get a nice seal, and then crank that down with a wrench and a wrench. If you can, get the right tools for this so you're not grabbing things by parts that don't want to be grabbed by. Helpful tools, by the way, are going to be some wrenches, either adjustable and or fixed size box wrenches, and pipe wrench or two, so that you'll be able to grab and tighten things that don't have a hex fitting on them. So this is a on-off ball valve. It means that we can fill this thing and then close that. It's not going to leak air out the backside. You could also use a check valve for this, but this was more readily available at a typical hardware store. So then next up, I'm going to use, I think this is a 4-inch, 1/4 inch pipe nipple, and the reason for this one is just so that I can clear that handle when I go into my regulator, pressure regulator with a gauge on that. And so this allows me to regulate the pressure so I can tell how much I've got in the tank when I'm filling it up. And then we'll go to another shorter pipe nipple. So that's our setup. So this is all input. And then we're going to use a T junction and move from 1/4 inch into 1/2 inch world at this point. So if you get this kind of little bushing here, this is the most common way, I think, to get your adapting from 1/4 to 1/2 inch. So we'll screw that into the T. And now we're basically 1/2 inch everywhere else. You could go up to 3/4 at some point if you wanted to get maybe a bigger, like one burst of all your air as fast as you can and a louder sound, but I'm going to keep this at 1/2 inch. So this T then goes down to the tank. So we'll get another, in this case, a 1/2 inch nipple. So that's what's going to go into the tank here. All right, so we'll screw that into there. So that's all of our air input. And then everything from here forward is the solenoid valve and the output, so that we can decide when and for how long to let air out of the thing electronically. That's the part I don't have right now, unless it came since I started the show. But I'll show you the part I'm going to try. It's we have a 12-volt solenoid valve in the Adafruit shop. It says it's for water, but I think actually I looked at the data sheet and it's for water or gas, air. I think it'll work fine for this. So this will be to go into that female threaded. A lot of those types of regulators and solenoid valves are female threaded. So that's why I'm going with this little 1.5 inch pipe nipple that's 1/2 inch diameter to go into that. This is my stand-in actually for now. This kind of does the same thing as that valve. It's just not electronically controlled and it's not, instant on off. This is another ball valve to cut that flow. These are sealed, they don't leak. You can see inside of them there's a sphere with a cylinder bored out of it and some Teflon washers that keep everything nice and sealed. So that's going to go there. I may keep this in the system so that, again, I don't have to rely just on my solenoid valve to hold the air in the tank. This is kind of optional. The solenoid is supposed to do that, but I don't think it's a bad idea in any compressed air system, water system, to have a couple of ways to let air through or off. These types of valves, by the way, they are open when they're in line with the system, and they're closed when they're perpendicular to the system. So it stops, lets it through. This right now is going to let it through, so I'll close that like that. So that's going to stop the air out. So then we'll have another short 1/2 inch by 2 inch galvanized nipple. You could use black pipe for this as well. There's not really going to be much difference. They're usually about the same cost as well. You can decide how you want that to look. So this will then go in to the solenoid valve, and then from the solenoid valve we'll go to sort of our barrel here. So I've got like a 12-inch section of 1/2 inch pipe there. So at this point it looks kind of like a marshmallow launcher. And I'm just going to kind of hand tight this enough that I'll still be able to take it all apart and put Teflon tape and put it together properly with photographs. But for now, let's just kind of finger tight-ish that. Like that, sure, that'll work. Now, one thing to point out is this sort of system is actually a better bet than PVC pipe, just from a safety standpoint. PVC pipe, putting it under high pressure, it's not anywhere near as safe as a galvanized pipe or iron pipe. So not to say that people haven't, including myself, built a bunch of PVC high pressure air cannons in the past, but it's if you want to do something that is actually in some ways easier to put together, because you're not dealing with PVC cement, you're just threading stuff. You know, you'll put Teflon tape on the ends, tighten them up, and off you go. But that is another option for these things. So I'm gonna, let's zoom out a little bit more here. You can see I've got my Discord going with some GIFs going. Oh, we got plumbers, look. Hey, it's plumbers. Yes, so here's the air tank. Go ahead and, again, this will get Teflon tape in there. There is, you gotta be careful, you can cut yourself inside of there. There's also a little bit of flaking paint, so I may give that a little bit more of a washout before I do this. You could strive to make it more compact depending on your needs. You can, of course, use a smaller air reservoir. I think you can get down to maybe a 3-gallon air tank, and then after that you'll start wanting to use like 2-inch pipe, iron pipe with caps to make your own smaller reservoirs. So that may or may not leak, but I think it's worth a try, just charging it up a bit. Unfortunately, let's see if I can tighten this a little more just so I can see the gauge. Oh, main camera went out again. All right, let me flick that off and point this camera instead. Not the dreamy soft focus one, but that one for sure. Okay. Boop. All right, so you'll see me over there at least. Oh wow, Tyeth Gundry said it was impressively quiet for a compressor on a live stream. I think that's a testament to this tiny lav mic that's pretty dang directional and proximity based. So I guess I'm far enough away from the compressor. That's good to know that it doesn't blast your ears. Let's see. How can I get that flipped? Can I tighten it? Yeah, sure. Why not? There's enough things to tighten to see that gauge. Why not? Okay, so I'm going to keep this closed so that we're not letting air out. Leave this open so that we can fill the tank, partly at least. Attach my air line here. Give that a little turn. Nope. This one. And I'm going to fire this up. And I'm getting a few little leaks, not surprisingly. Okay, so yeah, I hear it leaking right here. Let's see if we can. Oh, where am I going? All right, yeah, stopped some leaks. Okay, so yeah, we still got about 20 pounds pressure in there. Just so you can kind of see something happen, I'll set a piece of paper here and try not to drop my phone. Okay, so that's the kind of sound we'll get out of this until we put like a bigger resonator on if you're trying to go for a loud sound. If you go to haunts, you'll often hear these things happen as you trigger a thing or open a door, or a baddie jumps out, and you'll see zombie wigs fly around a bit. So in fact, I don't think I have a readily accessible wig to use right now, but that'd be the idea. Additionally, you can use almost this identical type of system to move pneumatic props around. So things that jump out of trash cans up and down will often have a two-port valve, so they can essentially push and pull. Air goes into one port to push it up, and then air goes into the other port to pull it back down. So knockers and skeletons that pop up and arms that come out of trash cans, those can be run off of a pretty similar system, just a different valve in here. We're going to use the simplest kind of valve for this, but there's a lot of possibilities with it. Okay, so we just let it out. So that was at, I think I had maybe 20 pounds, 30 pounds, can't remember, in there when I started. And that gave us, a few blasts. So you can have your compressor further away, so it's not quite as loud. You can have a bigger tank that you're filling this tank from. You can just be refilling when you're refilling, also depending on how much noise you have. You can get bigger tanks than this. 7 pound is another one. 11 pound is another one you'll find at hardware stores, all the way up to as big as you want to get. But these are also sometimes used just as a one-shot thing, so you can have cannon effects that just blast everything out at once. So that is the idea behind that. You can also make it more compact using some shorter fittings in some cases, a check valve instead of this ball valve, elbow. You can put a 90-degree in it if you want to redirect stuff, keep it small, a couple of 90 degrees, and point the thing that shoots out backwards, whatever you want. Those are all possibilities. And once you get enough Teflon tape on there, you can kind of keep a seal and still have the ability to have some amount of angle on that. So a lot you can do with it, and not that expensive. I think I'll add up what I bought for this, but you can build it yourself for probably half of what you can buy it for from a supplier. So I'm guessing we're in the $100 range for what we're looking at here. Don't quote me on that. I'll have to add it all up, but not too bad. And I've seen these really similar units on haunt sites going for like $500, $600. Now that is the sort of nuts and bolts of the thing. What my plan is to take that solenoid valve that I'm driving from a relay. Let me show you what these parts are going to look like. So if you look at 12 volt solenoid valve, this one right here, it is a 1/2 inch. It says it's a brass liquid solenoid valve. I think this is actually going to work just fine for air as well. It looks identical to ones that are all over the internet as air valves. And if you look at the data sheet on it, water, air are listed pretty prominently there. So I suspect this is the same product, and it works for those just fine. Apparently it can do oil as well. These usually come in a variety of operating or triggering voltages. Your fastest is going to be on this one using the 12 volts, and it draws about 3 amps. So I'm going to use a 5 amp power supply, I think. The These also come in 24 volt DC. There are 110 AC, 220 AC. So we'll be running this from 12 volt in our case. And then to trigger this, we'll use a relay board. And this is the power relay feather wing right here, which has enough, can run enough current through it to drive that, I think, no problem. These relays can allow AC or DC through, so we'll be allowing 12 volt DC through this. And then we've got ultrasonic distance stemma QT. I think probably this one here. I think this is the one that the Ruiz brothers just used for the pumpkin prop, in fact. Yeah, prop maker jack-o'-lantern. So this one we can set at a variety of distances to do different things. Since it's the prop maker, what I may do is I may keep this simple and just say here's how to make it trigger the air cannon. Mark Fox, who just said, I came in late, what am I making? I'm making an air cannon that'll be a Halloween haunt prop. So either for blowing air at people's ankles, don't shoot people, making a bunch of noise with a resonator on the end, firing off confetti, whatever you want, and it'll be triggered electronically. So with the prop maker feather, RP2040, this will allow us maybe to have some audio on there. Not going to be super loud, so it might be better to go through a bigger system. But you can have audio, you can have neopixels, and they screw right in, no solder required. It's pretty easy to set up. And then the trigger, ultrasonic distance trigger, will be in there. So we could do things like at some distances, turn on lights or change lights. You could, of course, go as simple as just pressing a button when you want to launch a thing, and maybe you want light and sound and triggering. So those are all things that'll work pretty well with the prop maker as the driver for it. Question from the chat: does the tank tap? Does the tanks tap to empty any water that builds up? This one doesn't. You will get condensation in these kinds of systems, and on this one, the literal directions are put 10 psi in it, turn it upside down, open your valve of whatever's on one end, and let it spurt out. So that's a good question. You might be able to buy a better, more expensive tank that has a outlet for the dripping of water buildup in there. And I think there are things you can put between your compressor and this that will try to pull out some of the moisture. So there's options there. And I don't know. I live in a pretty dry environment in Southern California, so I don't know how important that may be in October in New Hampshire or something. If you're building this, it's probably a different ball of wax. So let's see. Andy says you could make a tiny one with those aerosol air dusters. That's cool. Yeah, you know, I think Andy also says you could attach a vuvuzela to it. Yeah, I mean, noisemakers, it's a great idea. If you put noisemakers on the end of this air horn kind of things, you can make a lot of sound. Starman works good for a ghost. Inflate rapidly after it falls back. Yeah, good for blowing like sheets and stuff like that, billowing stuff. You can also get manifolds and have your air come out a few different places depending on what you're doing. So there's a ton you can do. This is just like the most basic beginning stages of it. In fact, speaking of the most basic beginning stages of it, I have, can I get it down easily? Let's try. I have up here one of the, I haven't gotten this thing down in forever. I have one of the air cannons I built for the Make TV show. It's been just sitting here for ever and ever. So this is the same idea, except it's make the reservoir with a bike valve on the end out of PVC, reduce it down to the solenoid valve, which happens to be a sprinkler valve. And then there's the control box that's just, I think, in this case, I think it was just 9 volts, like a 9-volt battery, 9 volts to the solenoid. And then this is where you load in your T-shirt or your whatever that you're firing. So pretty much the same idea, but I like to think that making the iron version is a bit better, a little safer. So that's the new version. All right. Anything else that people have questions or tips or thoughts about on that? Let me know in the chats. I will be putting this together, taking photos, doing it with my Teflon tape on there, tightening things up properly. Solenoid valves should be here, I think, today or tomorrow. And then I'll start putting together the software side of it, which will be pretty straightforward. You could also do remote triggering off of Bluetooth if you wanted to. It just depends on the feather that you have there, or if you add airlift or other side boards to the feather. But if you use like an ESP32, you could trigger it, or a NRF 52840, you could trigger off of Bluetooth. So there's a lot of options for this once you have your electronics set up to take a control voltage and open up a relay and allow 12 volts through to the solenoid. Someone said, Andrew Ford said, if you have access to a scuba tank or other commercial filled vessels are usually very, very low moisture. Oh, that's good to know. A step up from this that maybe I'll explore in the future, maybe for next Halloween, is you can use CO2 tanks, which just compress a lot more in a smaller space. So you can have a lot more air on tap if you fill up like paintball canister CO2. You can make miniature versions too with like little, 12 gram or whatever those are, 15 gram CO2 cartridges. Just depends on the kind of effect that you're going for. All right, I think that is going to do it. So that's kicking off that project. And then last thing I wanted to do, I threatened to do it, and let's actually do it, is I wanted to talk about doing a little bit of basics of CAD. I don't know if I'll need to do any CAD work on this project. Maybe I'll mock the thing up in 3D so it's easier to do diagrams of it. But I'm going to jump over to my view here of my CAD software. So basics of CAD. I don't know how, at what level people are interested in this or what level of knowledge you have already. So as I said, I don't want to necessarily do hey, I will teach Rhino in specific, but that's the program I'm going to be using it, but it's commercial software that's not free. So, you may want to look at Blender or OpenSCAD or other free software to start with, or continue with forever. There's nothing wrong with any of those packages. So just to get that out there, I'm not using this as a specific advertisement for or call to arms to use this software. It's just the one I use the most and the one I'd like to show things in. So the starting things I'll talk about in CAD and 3D, and this will be a rapid fire version of this, are translation in 3D space, as well as the differences in 2D and 3D. So this is a typical view you'll see of the world in CAD, which is a 4-view of your scene, which has a top view, a front view, and one side view, sometimes left, sometimes right. Any of these can be flipped. Top can be bottom, front can be back, left can be right. And then some sort of a perspective camera, and this can have no perspective to it, but just be free floating, so orthographic, or it can have some sort of lens that isn't a parallel projection. So this one has a perspective lens of some kind. Movement happens in 3D space in what's usually described as X, usually horizontal, Y, sort of forward and backward in the scene, or from a top view up and down, which is a callback to 2D, and Z, which tends to be up and down away from the ground. This transform can apply to translation, moving stuff around, to rotation. So here I'm rotating around the Z-axis, here I'm rotating around the X-axis, here I'm rotating around the Y-axis, so X, Y, and Z there. And for scaling things, so these are sort of the primary transformations, so I can just make it taller by scaling in Z. I can make it wide by scaling in X. I can make it deeper by scaling in Y. All right, so this is a basic form, and these forms can be a whole bunch of different geometry types. So you can have, by the way, I should mention, I know this camera view of the world is gonna stutter a bit, but the smooth camera that I can do coming through this broadcast software doesn't show the cursor. So it goes into what it calls game mode, and then it refreshes faster for broadcast, but you can't see the cursor, which is a little hard when you're showing this sort of thing. So apologies for it being a bit stuttery. Let me zoom out a little bit here. The mode of working can be just a single view. So we can just often find ourselves in one single view. A lot of times that's a top or a front view when you're planning things out, laying things out. You can do a lot of modeling things in a perspective view like this, an outside camera view that you can control. And the type of your geometry will matter at some points, but I'm not going to worry about it here other than to say I'm working with solids and NURBS for the most part, which you'll see they tend to be represented parametrically or mathematically as a description of a surface, not a discrete, almost rasterized version of lots and lots of little polygons. You can do that. You can tell a thing to be a polygon mesh, and we can, let's see, can I make this look full? I can't remember what setting will do that. No. All right, that'll be a better thing to show another time. This is such a simple object that it'll look kind of the same as polygons. When I talk about 2D versus 3D, so often in CAD what this means is we can start our project as a drawing. It's particularly something that, one second, that is the nomenclature used in something like Fusion 360, where we can say, okay, I'm gonna build two-dimensional lines that are kind of all stuck on a single plane. So this top view is a good example, and maybe I'm outlining what my object is. Let's say I'm taking a feather board and I want to build a little box for it. So you may start with all sort of dimensional plan drawings. Speaking of dimensional, I tend to work with a millimeter, a small object millimeter type of template and units. So that means I can do things like start drawing a line and say, oh, I want this to be 60 millimeters long. So now it's waiting for me to set down a line that's 60 millimeters long. And I know the thing needs to be, let's say, 40 high. So I'll start a new object, a new line in this case, and say, okay, you're going to be 40. No matter where I set you down, you're 40. So now I've got the beginnings of something that's dimensional. You may be doing things like putting holes in for screws to mount stuff. So I can say, okay, yeah, I know I want like 3.2 millimeter holes, since I'm going to put M3 screws through them, and then we can start placing them around. Now, the other really important thing that goes hand in hand with dimensions is the ability to snap objects to a grid, to each other, to spaces that are an offset from an object. And you may have noticed as I'm doing things right now, it can be hard to tell because I have slow refresh on the broadcast, but as I'm trying to move this thing around, you can see it's snapping to a grid, a 1 millimeter grid in this case that I have, which can be useful. You can see since I started my lines on the grid, and I can place this circle on the grid, I can maintain some sort of nice symmetry here. But we can also take things off the grid. I'm just going to turn off grid snapping and place things kind of much more precisely where we want without snapping to some particular spot on the grid. Or we can get specific about relationships to other objects. So let's say I want this to be at the midway point of both lines. It should just be in the center point of both of those lines. I'll just do a visual guide for now so you can see it, but as I go to draw this line, if I hover over something existing, I get a little pop-up that says midpoint. And again, this will vary depending on the software you're using. But if I click on that and then start to drag along and then go and hover on this other line, I can extract a midpoint snap there as well. So now I know this line is right, this end is right at the midpoint of both of those lines. I could have done that just with the circle, but to show something on screen, I've now drawn a line that is where I want this to go. So now I can simply move the center of that circle to that line, and now I have a midpoint. Now, typically, rather than working with individual lines, we'll use something like a rectangle to describe a box like that. So I'll go ahead and either draw one fresh or use those same tricks to draw some lines that are aligned. So I'm just going to make 2 more lines that snap to the ends of those lines. And these right now are sort of free floating, so there's another important concept in dimensioning out your starting 2D stuff, which is joining stuff together if it can be joined together. If we pop out here for a moment and look, these all live on this one plane, so they touch each other. They're not some farther away and some closer to this top view camera. They all live on a plane. If they didn't, we can project them to that plane to fix that problem. But with these selected, I can join them, and you'll see with this program I type commands in, so I didn't have to look for a menu item or an icon or something. I just typed in the word join. It'll autocomplete or give me options of things. I don't think you're going to see that. That's a separate window, yeah. But you can see the little word join up there. When I type that, it pops up and says, okay, 4 curves were joined into one closed curve. So closed and open, important concepts, particularly for stuff like 3D printing. Very often we're trying to make watertight objects that will 3D print properly. So this is now a rectangle, and I could have made that with a rectangle tool, but I've made it from 4 lines that are now 1 line. Once stuff is joined up, and these are the last couple things I'll show you here today, once we have our 60 by 20 millimeter line, and I can verify that with some little dimensioning tools. I just asked it, hey, how long are you? It said, oh, that's 60 millimeters. We can also put dimensions on the screen if we want to make like a little plan drawing that people can use for in some other way, and just look at it and see what the dimensions are. We can do that too. What I can do with these is modify these existing curves. So a common thing to do is to put a little bit of a radius in the corners, a fillet. So I'm going to type in fillet corners, and I'll do let's say 0.5 millimeter. I'll go back to the top view so you can see that. So now I've got nice little roundy corners there, and this is really nice when you're 3D printing stuff, so it doesn't come out kind of sharp. 3D printed stuff can be pretty sharp if you just put right angles in there, and you'll notice a lot of, in fact, most objects that you deal with in life have maybe not as extreme as Apple products, who love their radiuses to be big, but even this little breadboard right here, the corners are not perfectly sharp because, ouch, so there's a little bit of a chamfer or a fillet in there. So I've added a little chamfer in here, and now I'm going to extrude this into an actual 3D object. So I've started with a 2D thing, and then you can extrude stuff. Let's say I'm going to make this 30 millimeters high. Now I have extruded the curve as essentially a set of walls. I'm going to cap it so that it is now kind of a solid filled object. We could 3D print this, we would have a hunk of plastic, or we could start to use other techniques that I'll show in the future if there's interest in how to turn this into maybe a box that's got a lid that you can print in two pieces, something that you can screw your electronics into and have ports carved out, etc. But those are just some real basics of doing a 2D set of lines with a particular dimension and then turning them into 3D. You can kind of ignore, I'm not going to make any of those holes today, so that can live off to the side. And what I'll do if people are interested is some of this manually and then show how to do it parametrically, which is a pretty common approach, especially when you want to reuse your designs for different boards, for different scenarios, and you don't want to do everything from scratch again. You want to be able to change your mind and say, oh, but what if I wanted this to be 50 by 80 with a different radius for it? That is where we'll get into parametric design, which exists in different guises in different software, but you will usually see little nodes plugged into each other with info and sliders and things. So I'll show you how to build that kind of stuff. In Rhino, it's with the sort of side app that's called Grasshopper that does all of this parametric stuff. All right, so we'll call it there. That's a little bit of basics on CAD, and I'd be interested to know if you're interested. So before I go, again, let's not forget it is Octo month, the 8th month of the Roman calendar. We call it October. And it is your coupon code. So if you want to head to Adafruit.com, throw some stuff in your cart, get 10% off, type that in. On the way out, those prices will come down. So don't forget to head to the store, get some cool stuff. It's what we do. It's how we keep the lights on. It's how we keep ourselves in plumbing supplies to make our air cannons. And I'm excited about this project. I'm looking forward to demoing it. Hopefully next week we'll be able to do some firing of that. Right, I think that is it. So thanks everyone in the chat. I'll just take another look to see if there's any questions before I go. Yeah, someone, John Nodge was saying lefty loosey, tighty righty when I was grabbing the pipe with the pipe wrench in the wrong orientation there, I think. Yup. Let's see. Other questions? No. Novelty auto relighting candles don't stand a chance. Yeah, you can bring this to your birthday to blow out the candles if you want. Inflatable Lars, that's horrifying. I really like that though. Let's see. Andy, great workshop. Was feeling deflated when I came here. C. Grover, the CAD intro discussion is helpful. Okay, yeah, I'll do some more with that as long as people are interested, because I find it interesting and it's fun to do and useful. Maybe we'll even laser cut some stuff and 3D print it. Okay, I'm going to call it right there. We've gone a little bit over. Thank you everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.